All right, in 7.3, we're going to be doing double angle and half angle identities. There's a third one that we don't really cover. It's called the reduction identity, and I've literally never seen that being used other than in this lesson. So we're just going to do these two. So deriving the double angle for sine and cosine. So we start with the sum formulas. All right, and we're going to say that the angles are the same. So let's say we have alpha and alpha. Okay? So we're going to call them theta. Actually, let's find theta. Sine 2 theta, okay, equals sine theta cosine theta plus cosine theta sine theta. And if we look at these two, they're the same. So sine 2 theta equals 2 sine theta cosine theta. Okay. If we do the same thing with cosine as well, call alpha and beta theta. So we have cosine theta, cosine theta, cosine theta, minus sine theta, sine theta. And these two, okay, that's cosine times cosine, cosine squared. And then sine squared plus times sine squared is, let me try that again. Sine times sine, sine squared. This is not the same as the Pythagorean identity, because Pythagorean is a plus sign. So using that Pythagorean identity, sine squared plus cosine squared is 1, we can replace either cosine squared or sine squared. So I'm going to replace cosine squared with 1 minus sine squared. We still have this one. So 1 minus 2 sine squared. So cosine 2 theta, double angle for cosine, has other variations. Okay, and in that same regard, I can change this one. Be a little bit more careful on that one, because we bring down the cosine squared, bring down the minus. Now sine squared could be 1 minus cosine squared. But because of this minus sign, you 100% need the parentheses here and here. So we'll distribute that minus sign. And then I end up with cosine squared, cosine squared. I have 2 of them. So we have 2 cosine squared theta minus 1. So you can use any variation of the double angle for cosine. It does not matter which one you use. It kind of depends on the information that you have at that moment. Same idea with double angle for tangent. Replace alpha and beta with theta. So we get tangent theta equals tan theta plus tan theta over 1 minus tan theta tan theta. If we simplify that, I've got 2 tangent theta in the numerator because I have tangent plus tangent. And I have 1 minus, we have tangent times tangent, tangent squared. All right, so to put those all together, double angle for sine, all the variations for double angle cosine, and then double angle for tangent. Okay, using those, okay, I have given that sine alpha equals 5 over 8. Alpha's in quadrant 1, which means we don't have to worry about sines. Find cosine to alpha. All right, I have sine alpha. So I'm going to use the cosine formula for that just has sine. So that's this one. All right, so cosine equals 1 minus 2. And then it says sine squared right here. So sine is 5/8. So 5/8 squared. So 1 minus 2 times 25 over 64. All right, you can use your calculator at this point. I'm going to do it without right now. So 2 goes into 64, 32 times. So we have 1 minus 25 over 32. So we have 32 over 32, getting that common denominator. Let's see. 20, so that's 7. 32 minus 25 is 7 over 32. And guys, I am 100% okay if you get to this point, you can put it in your calculator. In these two examples, we're verifying the identities using double angle. All right, so I've got cosine to the fourth minus sine to the fourth equals cosine 2 theta. Remember, we want to use the more complicated side. In this case, that's going to be this cosine to the fourth minus sine to the fourth. That is a difference of squares. All right, even exponents are squares. When you take the square root of an even exponent, you divide the exponent by 2. So cosine to the fourth, its square root is cosine squared. Sine to the fourth, its square root is sine squared. Remember, these are conjugates, so we add them and subtract them. Okay, so cosine squared plus sine squared is 1. Cosine squared minus sine squared, if we look back up here, that's there. That's cosine 2 theta. And 1 times cosine 2 theta is cosine 2 theta. So we got the left side to equal the right side. All right, in this instance, I would say that the right side actually looks like it's more complicated than the left side. You can do either side on this one. They're kind of pretty evenly spread. And the reason I'm saying do the right side is because I have a common factor, cosine. So if I take the cosine out, take it out of here, and I have cosine squared left. Take it out of this term, and I have sine squared left. Well, that's sine 2 theta, or cosine 2 theta. Which is what I have here. Different order, but same thing. So did I turn the right side into the left side? Yes. Okay, so our half angle formulas, I'm not going to spend the time deriving them. These are the half angle formulas for sine, cosine, and tangent. Tangent has a bunch of variation. It just kind of depends on what you know at the time. The hardest part about sine and cosine is which one it is. Is it plus or minus? Is it plus or is it minus? All right, so doing these two examples, given that tangent alpha lies is 8 over 15 and alpha lies in quadrant 3. Okay, we got to consider. Look, let me back up. All right, sine alpha over 2, so half angle. All right, I know that this is y and this is radius or x. And if I go back and look at the formula for sine, I need cosine. So I'm going to go over here, kind of off to the side, and we're going to find the radius, because cosine is x over radius. So I've got x squared plus y squared equals radius squared. So that's 289 which is 17. Okay, which would make cosine alpha x over radius. Since we're in quadrant 3, this is negative. Okay, now I have the formulas in front of me. All right, so the formula I'm using, just so you know where I'm getting them from. So I've got plus or minus square root symbol. And we have 1 minus cosine alpha. So that's 15. That's at negative 15 over 8. That's a lie. Negative 15 over 17. Over 2. All right, so I'm going to add these two together. Okay, and the reason I'm adding them is I have minus the negative, which is the same as plus positive. You can 100% do this in your calculator. I can do this because I know that 1 is 17 over 17, and I'm adding 15 over 17. So I add those two together, I get 32. And this is all over 2. And ooh, that's terrible. Okay, I'm spending too much time trying to get that square root sign looking good. So we end up with the plus or minus square root 32 over 17 all over 2. 2 is over 1. So I am going to multiply by the reciprocal. 2 goes into 32 16 times. I'm going to kind of go out this way. So I end up with the square root of 16 over 17. Square root of 16 is 4. Get the radical out of the denominator. Okay, so now I've got to figure out if this is going to be positive or negative. Okay, so let's consider that it tells me that the angle is in quadrant 3. Okay, so angle is in quadrant 3. So that's terrible. So I am down here. If I take half of that angle, okay, whether it's 269, whether it's 181, that half angle, if I take half of that, it's going to put me in quadrant 2. Okay, in quadrant 2, sine is positive, cosine is negative. So when I'm looking at this, I have plus or minus. This one's going to be the positive square root. In example B, I'm going to use the tangent formula, which I have here and there. So I'm going to do everything I can to not use a square root symbol. We're going to use one of these two, and it honestly does not matter which one you use. Okay, I chose that one because I can. So sine alpha was, let's see, sine would be y over radius, so 8. Let's go ahead and put it over here. Sine alpha would be 8 over 17. Quadrant 3, sine is negative. Okay, so I've got negative 8 over 17 over 1 minus cosine alpha. 1 plus cosine alpha. Make sure you read the formula correct. All right. So this is going to be 1 minus, that's going to be basically 17 over 17 minus 15 over 17. So that's 2 over 17. Multiply by the reciprocal. 17 cancels, 2 goes into -8, -4 times. And we get -4. Okay, given that sine alpha is -4/5 and alpha lies in quadrant 4, find the exact value of cosine alpha over 2. Okay, so I've got alpha. I got sine alpha equals -4/5. That's y over radius. I'm going to go ahead and find the x. Okay, so x squared plus y squared equals radius squared. Okay, and for quadrant 4, I know that the x is going to be positive. All right, so the formula I'm going to use, the one for cosine, okay, plus or minus, really big square root symbol. That's 1 plus cosine alpha. 1 plus quadrant 4, so cosine alpha over 2. 1 plus, remember that's 5 over 5. That's terrible, but this is 8 over 5. All over 2. Imagine that 2 over 1. 2, 8, 4 times. I'm going to go sideways. So I have the square root of 4 over 5. So that's 2 over the square root of 5. Get rid of that radical. So 2 root 5 over 5 plus or minus. Okay, so let's talk about angles that are in quadrant 4. So we're down here. I consider where half of that is going to take me. So let's say I have my smallest angle possible is 271, and I do half of 271. That's 135 degrees. All right, so that puts me in quadrant 2. If I do anything bigger than that, let's say I do 359. Okay, that's 179.5. That's still in quadrant 2. Barely, but quadrant 2. All right, so cosine is negative in there. So we use the negative square root.